ಆಯಿತು. ಎಕ್ಸ್ಟೆಂಡ್ ಆಗ್ತಾ ಇಲ್ಲ. ಯಬ್ಬಾ ಬಾ, ಈ ಶನಿ ಒಂದು ನಿಮಿಷ. Just a minute.
Is the voice clear? Is voice clear? No, voice is clear. Just first tell me. There is some problem because whatever I try, I am not able to adjust this what we call is setting for so. So I bought the tripod nearby. Okay. No. What happened is whatever I tried. See, usually if you want to enlarge, you have to do this way. It is not activating. I don't know why. Some problem. But still, image is okay. Video is okay. No. Video is okay. We shall continue. See, these decorations all I am not bothered. The decoration part, people want systematically. Subject should be systematic, not other unnecessary things. Okay, I'll start. See, sometime no one will go this in YouTube. They will tell, see, trim dress, then neatly, nose time, correctly set for the board, and pre-plan it earlier. Okay, pre-planned everything. Show off is there. No, I believe subject is more important. Understand that one. Okay, one. Again, remember, I will tell you what happened. What happened is usual problem. Because of some, see, usually I always check. Today in the beginning, you wasted lot of time for not giving values. I forgot it. Otherwise, usually after 5 minutes, I just go around and check the charging. Today I forgot to check the charging. Charging went off. That's all. Charging problem. I told you always in the beginning of the class, just one message to me. What? Charging sufficient. Recording is not there. If it is YouTube class, automatic recording. I don't have to record. In Zoom I told you, remind me charging and recording. In YouTube class, you just one simple one message. See, someone told there, good evening. Okay, good evening, thank you, good evening. But at least charging. At least charging. I will see it and check immediately. See, this is called unnecessary waste of time. Of course, mistake is from my side, I agree. But I always told you, those who come to my class, you never think my class, nobody thinks my class as commercial angle. They know it is education oriented. So, little what? From your side, little contribution in the beginning. I don't ask you doubt for subject. Charging, that's all. Okay, I'll continue. See now. I don't know up to where last time over. Okay. I'll tell a little later here. See. Spacing came 176.84. Maximum permissible spacing is 302.02. 2 meter spacing means people will chase you from the side. So, even 300 is too high. Tell me, what spacing you will provide? Tell the answer. What spacing you will provide? Required spacing came 176. At any cost, you cannot give a spacing more than this value. How much spacing? Round up the spacing. One light I will remove. Okay. I will remove one light. Okay. Now, that is giving glare there. This light I will shift slightly. Okay, now okay I think. See, now no disturbance. You will go for 12 torr at 175 center to center. Okay. That is 176.84. We will round up to 175. This will complete. Therefore, remember, later, see, I will put this sketch once again. You don't write. So, this AST for lengthwise bending is what? 16 torr at 175 millimeter center to center. Correct? Clear now? AST provided. This AST provided for lengthwise bending is 16 torr at 175. We will change it later. No problem. Clear now? 16 torr at 175. Clear? Clear or not? That is AST for lengthwise bending. Fast. Okay. Now, see, I am changing here. Consider widthwise bending. Start once again from here. Bending moment is how much? 317.6. Okay. Then, equal to, same formula, tell me AST required first. change AST. AST required first. Instead of 323.1, now it is 317.6. AST required. How much? AST required. First. Solve the quadratic equation, get AST required. We should finish this question today. Otherwise, I thought I will tell one more information about the central band of rectangular footing. Okay, tomorrow I will tell it. Tomorrow I will be very careful. See, I prepared a extended class earlier only. So, but it takes at least 7-8 minutes for activating after what? Charge is gone. This particular mobile takes at least 5-6 minutes. Till that time, it will not get on. 1116.96. So 1116.96. Minimum remains same. So you have to provide 1116.96. Spacing. How much spacing? 1116.96 into 1000. Spacing. How much spacing? Spacing. For 1116.96. Okay. 1117. Okay, why Chaukasi? Take 1117. Okay, now tell me. For 1117, spacing. This much time. 179.94 millimeter center to center. Maximum remains same. Therefore, provide 16 torret. How much? Tell me. 16 torret. How much? Round off. When you round off to lesser side. 180 you can't give. Sorry. See, when you calculate spacing, strength point of view, okay, someone will tell 117.94 is almost equal to 180. Or I will do one thing now. I will use the value. So I will make a small mistake here deliberately. Why? So that I see 179.94. You cannot make 180. You have to make what? You have to make 175. If you make 175, both will become same steel. Make a note. I do not want same steel for both. So, just for understanding purpose, I will make a deliberate mistake here. Instead of 1116.96, I will make it 1114.96. You write here. Deliberate calculation mistake in the class so that purposefully made. Practically don't do it. So, I will change it to deliberately. What? 1114.96. And now tell the answer. 1114.96 spacing. This is just to see that the two steels are different. That's all. Now spacing. How much? This is a deliberate mistake or mistake done just to see that two steels are different. 180.23. 180.23. Therefore, now you can provide 16 torret 180 mm center to center. Clear? Somebody will tell. Someone will comment. You can't take less. I am taking deliberately. Don't take practically. Therefore, this steel equal to 16 torr at 180 center to center. Fully clear? Therefore, remember, lengthwise bending steel is 16 torr at 175. Widthwise bending steel is 16 torr at 180. And later, I will change it. Fully clear? Full clear or not? Lengthwise bending, widthwise bending, both steel. Okay. Now, the most, I will rub everything now. Now we are going to most important part. See, I will remove everything now. This all I will remove. This also I will remove. This also I will remove. See, this, now, one heading you are trying. Now, check for shear. Remember, check for shear means which shear? One-way shear. Not punching shear. One-way shear. Or some people call it wide beam shear. wide beam shear. Some people call it, or it is a shear which causes diagonal tension. See, which will create tension crack this way. Diagonal tension crack. Somebody will ask, sir, shear, how it produces diagonal tension crack? Go back to strength of materials. There it is discussed. But for those in the RCC batch and also for ETAB batch, this I told earlier during beams. Yes or no? Those in the RCC batch and also in the ETAB batch, long back in shear, I told this diagonal tension. Tell me yes or no? Those who are in the respective batches. I told there, general public, if they are viewing only from YouTube, you believe me, that's all, you believe me. I cannot for your sake leave the subject and go to complementary shear all. Okay, start. Now, remember now, or you can call this as simple language, our usual shear. Some will tell, what is usual shear? I will tell them. It is between me and my students. Don't interfere. If you are my student, don't question me. That's all. Okay, start. Tell fast. Critical section. Remember, make a note. Section for this shear is to be considered. Tell me, at what distance from face of the column? What distance from face of column? First, critical section for this shear, crack will run at 45 degrees. That was punching shear. Punching shear critical section is at D/2 from face of column. For this shear, critical distance at D, no D/2. That is at how much? D how much? Oh, forgot. Tell me D value. I forgot the D value on everybody. Remember, D equal to, how much D equal to? Forgot the answer. 676 millimeter. 676 millimeter. Okay. That is at what distance? That is at 676 meter from 0.676 meter. Okay. 676 meter at 0.676 meter from face of column. Remember, D is 676 millimeter. Why meter? Because when you are considering shearing force, we are referring this diagram. When you refer this diagram, we want dimension in meter. Okay. Now, do one thing. Start. Now, for all those who want to thoroughly understand, once again write this sketch. Once again write this sketch. Once again write this sketch. See, good for health. All these sketches, write once again. Then, note, write all the sketches. Remember, once you get control, what you can do is, no, this sketch is already there. So, use the same sketch by dotted line mark it. But this time, for a thorough understanding, to make it completely independent, what you do? Write all the sketches once again. Then, first consider lengthwise bending. Okay. When you take lengthwise bending, what do? Mark critical section. See, mark critical section. Start. See here, from the face, this side, which side is critical? See, it will be somewhere here. Now, 1.675, I will push that side. Hey, go that side. 1.675, I will push that side. See, from the, this is the critical section for shear. Okay. From here to here is D equal to 0.676 meter. Therefore, anybody can tell me what is this distance first. This is 1.675. Tell what is this distance. Why? For finding shearing force for a cantilever, I told you, you have to look free end side. Someone can tell me, I will look fixed end side. If you look fixed end side, you require a reaction which is only due to 1 meter strip for that one. Can you calculate? I don't know. Then keep quiet and look free and side. When I tell something, follow my statements. You don't try to advise me something else. It is beyond your capacity to advise. Answer. 1.675 minus 0.676. 0.999. Thank you. 0.999 meter. Almost 1 meter. No. Let it be 0.999. Now, I want shearing force here. Look this side. Look this side. This I repeatedly told you, cantilever. Either you believe me if you have not come to any of my other classes. If you came to my other classes, I told it so many times. Start. Now, I need this ordinate. So, by interpolation, tell me this is not required. I want this ordinate. Tell the answer. This is 160.3. This is 140 for a length of 1.675 meter. From here, you go by 0.676. Then it will be more than 140, less than 160. Tell me this value. By interpolation, first. By interpolation, tell me that value. First, today only required. Oh, interpolation, if it is not clear, I told you earlier what to do. You are forcing me to calculate, see. Is it 148 point first decimal 2 kilonewton per meter square, correct? This ordinate is 148.2 kilonewton per meter square, correct or not? Tell first. I will check the charge once again. I do not want once again charge to go. Oh, it is charging. Okay, it is charging. But actually charge is very lesser, because if you take live class, battery is consumed is more. Usually I put full charge so that even when the class is running, charge will remain same. But today we don't know. Charge is increasing slowly. Why? How much it is charged? 90% is used for live class. Correct. Okay. Now calculate shear force at critical section. Critical section. See, that is called V. I told you so many times. I think one example only I have given you. If you want shear force, look free and side. Only this much load. For when the loading is by trapezoidal or trapezium variation or UVL, total load equal to area. When you want bending moment, what you have done? The total load into distance you made. Now we want only load, right there. This also I explained earlier class. Only load means only area. How much? 148.2 plus 160.3 divided by 2 into 0.999. This will give shear force in kilonewton. Okay, answer. Sum of the two parallel sides divided by 2 into that distance will give the shear force. How much? Shear force. This every point was explained earlier before starting this question. If you go through that one, and if I don't tell all this again and again, this footing class will be over in 1 hour. That's what so many places I have seen footing design uploaded in 30 minutes duration. What they tell, what you understand, I don't know. What you tell, what you understand, I can't make out. They'll keep on telling. 154.1 kilometer. Okay. 154.1 kilometer. That is shear force. Okay, start. Now, calculate what is the shear stress. Shear stress developed due to shear force. Symbol is tau V. Remember, this is not punching, this is usual shear. Tau V equal to V by BD. Answer equal to shear force is 154.1 10 to the power 3 divided by B is 1000 divided by D is 676. Tell the answer in Newton per mm square. Fast. Tell the answer in Newton per mm square. Fast, fast. Someone is suggesting something to me. What? Sir, VU, sir. Yes, I know it. This mistake you are doing earlier, I wanted to trap you. I told you, this is the shear force due to what load? Tell me. This is shear force due to the pressure. The pressure was due to service load. So this is the shear force due to what? Tell me. That is the shear force due to what load? See, somebody calculated. See, you should not have calculated. Wrong. This is the shear force due to what load? That 154.1 is the shear force due to what load? This mistake I told you, criminal mistake it is. It is due to working load. Therefore, you require factored shear force. See, I left a gap. Sometimes when I leave a gap, students understand in Kannada, ಏನೋ ಇದೆ, ಏನೋ ಅವರು ट्रैप मारता इधर है कन्नड़ हिंदी भी थोड़ा गैप लिखा हुआ है, लगता है कुछ गड़बड़ है बिकॉज आई टोल्ड यू दिस मिस्टेक इफ यू मेक इट इज ए क्रिमिनल मिस्टेक. रिमेंबर, यू कैन बी प्रोसिक्यूटेड इफ प्रूव्ड. व्हाई? डेंजरस डिजाइन फॉर which will cause human lives are involved. You should never forget factoring. Did I tell this one so many times or not? Whenever you calculate a shear force or bending moment or axial force or twisting moment for working load, without forgetting, you get the factored values. Or do one thing, in beams or in the beginning only factor the loads. Okay, then you get the all the answer due to factored load only. Yes, so therefore factored shear force VU. See, I wrote deliberately V here. I was knowing, that's why I left the gap. Equal to how much? 154.1 into 1.5. Someone will tell it is not 1.5. For some combination it is 1 point. Keep quiet. I will tell them, don't interfere. Do you think I am not knowing? In the class, demonstration class, it is 1.5. If you take other combination, finally there also it becomes almost 1.5 only. Oh, I was not knowing. You are not knowing. Then how dare you comment? I will tell that way. You comment only if you know the basic concept. Answer. Don't forget. This is called criminal mistake. Yes, how much? 231.15 kilonewton. Therefore, VU is 231.15 10 to the power 3 divided by BD. Tell the answer. See, if you increase the depth by around 75% to 80%, punching comes safe, and usually this also comes safe. But if you don't increase, punching is unsafe. And this also will come unsafe. 0.34119 is 0.341. Sakbadi. 0.341. Remember, 0.341 Newton per mm square. Now to get what? To get tau C. Tau C means allowed shear stress. Allowed shear stress. Remember, tau V is danger. Tau C is welcome. See, to get tau C, use IS code table number 19. See, after taking classes for not 19 years into 38 years, furthermore, even now I get confused about table number. Some student will tell, sir, table number, page number, ask me, sir. I will tell within no time. Yes, correct. Principle. Sorry, sir. That is for you. By hearting is for me. Is it table 19? I think table 19, most probably. Is it table 19? Yes, thank you. Table 19. See, M25 concrete we are using. Okay, now, first you calculate, M25 later. If you want tau C, first you calculate PT provided. PT provided is 100 into AST provided divided by BD. Remember, now important, see, AST provided for lengthwise bending at present is how much? 16 torque at 175 millimeter center to center. First of all, I should not tell. This is spacing, but we want AST provided in what? In mm square per meter strip. Therefore, to convert this space, if you know number of bars, you people know how to find AST provided. When you know spacing, I told you use the reverse formula. See, or remember, AST provided equal to, what is the formula? If you take reverse formula, it is width B divided by spacing provided into cross-sectional area of 1 bar. If you want B, in the case of beams, steel provided equal to area of 1 bar into number of bars. But when you define spacing, then you have to use reverse scale calculation. This also I wasted time. Why? Already told. That is my nature, what to do. Or AST provided equal to width B is 1000, spacing provided is 180. Lengthwise bending is 175 into pi by 4 of 16 square will give AST provided in mm square for 1 meter strip. Answer. This will tell you what is the AST provided. It will be slightly more than AST required. See, the required AST was 1119 something. This will come slightly more. Why? Their spacing came 176. We reduced the spacing to 175. When you reduce the spacing slightly, steel provided becomes slightly more. Answer. Steel provided becomes slightly more. Instead of now it comes to 1148.34. Okay, thank you. 1148.34. Okay, now some space required. I will remove the space here. Why? This is not required now. See, now this is not required. I will rub this one. That I am not removing. I will rub this one to continue. Okay, start. Now go to IS code table number 19 for M25 concrete. M25 concrete. Tell the answer. You know PT, you know tau C. I'll put here space problem. You know PT, you know tau C in Newton per mm square. See, your PT came to PT. Oh, we are not done PT. Oh, calculate. Therefore, PT, you forgot. PT equal to how much? I forgot to calculate. PT here. 100 into AST provided. I written IS. Provided AST is 1148.34 divided by 1000 divided by 676. Answer. What is the PT? Tell me. What is PT? First. I forgot PT only. PT. 100 into AST provided by BD will give PT 0.1608 or okay 0.1608. Start. IS code told if PT is 0.15, tell me answer. If PT is 0.15 for M25 concrete, what is tau C? Table number 25, table number 19. For PT equal to 0.15, what is tau C? ಬೇಗ ಬೇಗ ಇವತ್ತೇ ಬೇಕು, ಒಂದು ವರ್ಷ ಬಿಟ್ಟಲ್ಲ. Today only required. It looks like you want to give the answer after 1 year. 0.29. Thank you. Very kind of you. 0.29 and for PT equal to 0.25 tau C. ನನ್ನ ಪ್ರಕಾರ 0.37 ಗೊತ್ತಿಲ್ಲ. ಫಾರ್ ಪಿ 0.36 ಓಕೆ 0.36 okay, this over. Therefore for actual PT equal to, what is our answer? 0.1608 by interpolation get the value of tau C. Tau C can be black color. Why? Tau C is good. How much is the tau C in Newton per mm square? Answer. For PT equal to 0.1608 tau C by interpolation. By interpolation. Answer. Very important now. So I am coming to closing part of footing. Remember, we are about to close the footing now. Next all design will be done by software. See, all further design will be, actually next week is the last class. I will tell you why. I will go for combined footing and give principle. Next Saturday I am going to finish all the manual calculation. Other Saturday we are starting laptop. See, laptop means what? Classes for ETABS&SAFE. Remember, the coming Saturday, Sunday will be the last class for you for all the manual design. So many are waiting for it, those who are in the group. So next Saturday, Sunday, I will go for manual design, closing part, over. See, such a long I explained. Other Saturday, that comes on 13th, I think, most probably. Then I am going for fully software class. It will be in the software class will be where? It will be using laptop, not on the board. Board will be used in between to explain. Everything will be on laptop. Laptop. I am trying to see that double vision is possible. One you can see laptop simultaneously, other one you can see board. I am trying for it now. Somebody is going to help me in Bangalore. So before that I am reaching Bangalore. So I will stay in the native place for at least around 8-9 days more. But I will reach Bangalore in time to start software class. 0.3038. 0.3038 Newton per mm square. Now see, therefore compare. See, therefore tau V, remember tau V is the actual stress. Tau V is the actual shear stress. Actual shear stress. Shear stress. How much answer came? Actual shear stress answer came 0.341. Correct? Yes or no? Actual shear stress came 0.341. Tell yes or no. Bega. Tell yes or no. Actual shear stress. It came 0.341. You have to tell yes. Correct. Whereas we got tau, this is tau V. Tau V means, see, tau V is danger. Danger. Or it is like your bill. If you go to hotel and happily eat, how much bill comes, that is tau V. Whereas tau C is the allowed shear stress. Allowed shear stress. Allowed shear stress. This is like how much money in the pocket. How much money in pocket. Remember, tau V is danger. Tau C is good. Why? More money in the pocket. Tau C you got how much? 0.3038. Therefore, your tau V is more than tau C. Therefore, tell me, safe or unsafe? Fast. Therefore, tell me, safe or unsafe? Fast. Your tau V came more than tau C. Good news or bad news? Tell me. Bill came more than the money in the pocket. Good news or bad news? Tell the answer. You happily spent in a hotel, eating everything. Finally, the bill came. Like how much? Bill came 3,410 rupees. When you count the money in the pocket, you have only 3,038 rupees. Good news or bad news? Bad news. Why? Bill came more. They will tell, go to kitchen and what? Grind the rice. Olden days. Nowadays they will tell, sir, card is there. Okay. So tau v is more than tau c, therefore not safe. Remember, make a note. Punching shear first drastically came unsafe. Then we increased the depth. Actually, we almost doubled the depth from beginning. Even then, punching shear escaped. This gave trouble. That shows that punching shear and this shear both are equally critical for footing slab. If that comes safe, usually this will come safe. But one thing now unsafe. Tell me, is it severe unsafe or marginal unsafe? Like, bill came 3,410 rupees. You have 3,038 rupees. Will there be a severe fight or some adjustment possible? Tell that. Or you tell in numbers. Bill came 341 rupees. You have only 304 rupees. Will it be very serious matter? He will shout at you and create a scene, or some settlement possible? Tell me. It is a marginal unsafe, some settlement possible. I told you, see, if the tau v is very high compared tau c, if it is severe unsafe, you cannot go for adjustment. What do you have to go for? Tell me. You make a note. This is marginal unsafe. Marginal. If it is marginal unsafe, I told you there is solution. That is called adjustment. Adjustment. Like in the hotel. Suppose bill came around, say you taken only one person, you go eat. Bill comes 320 rupees. Suppose you got 310 rupees. What he will do? He will tell, sir, 15 rupees shortage or 10-15 rupees shortage. He may tell, please give next time. Or he will tell, suppose nodkoli sir anta. But if the bill is 400 rupees, if you have 300 rupees, little severe case, he will tell, sir, when you eat, you should know. Okay, then what to do? But if the bill comes to 600 rupees, if you have 300 rupees, he will not let you go. He will tell, sorry, this is beyond the limit. Tell what you have to do. If it is severe unsafe, then only solution. What? Tell me. If it is severe unsafe, only solution. I told you earlier. You make a note. Severe unsafe means only solution. Increase what? I told repeatedly earlier, increase the depth and revise again. But if it is marginal unsafe, little adjustment is there. I told you, this is called artificial. See, it is marginally unsafe. So, this sketch I am removing now. See, from here, I am going here, upper side. I am removing this sketch now. It is not required for me now. That sketch is not required. So, I can remove it. Because I want everything in the board. Okay, start. Make a note. Make a note. Not a very severe case. ಕನ್ನಡದಲ್ಲಿ ಸ್ವಲ್ಪ ಶಾರ್ಟೇಜ್, ಹಿಂದಿಲಿ ಥೋಡಾ ಸಾ ಕಮ್ ಹೋ ಗಯಾ. ಓಕೆ, ಡನ್. ವಾಟ್ ಯು ಕ್ಯಾನ್ ಡೂ ಇಸ್ ಯು ಇನ್ಕ್ರೀಸ್ ಸ್ಟೀಲ್. ರಿಮೆಂಬರ್, increase steel, actually that is PT. When you increase the steel, remember it is artificial, not natural. In the deflection control I told you earlier, for a normal case, for marginal unsafe slabs, I told you, you can go to artificial. But remember, always natural is better than artificial. Increasing depth is natural. Increasing steel is artificial. Okay, done. Okay, increase steel. Now you have to go to reverse interpolation. Tell why. Now find for what PT, what tau c will, earlier tau c came 0.3048, shear stress came 0.341. Tau c will increase to how much? Tell me. Tau c from into 0.3038, that is little money you adjust there. Your friend, even 10 ರೂಪಾಯಿ ಕೊಡೋ, somebody else, 10 rupiya do, that way. You see that your tau CA will increase from 0.3038 to what value? This also earlier told you. First of all, I need not tell this one today, but I want this question to be perfect question. Increases to what value? Tell me. How much? Tell me. No, decrease spacing is okay, agreed. First you tell me, I told increase, what is this one? Increase the steel only. I am not written increase spacing. Oh, you are advising me? You are advising me? Can you advise me? First of all, tell me, can anybody advise me on technical matter? Technical matter. Anybody got courage to advise me? Is it possible? I told you increase steel. I know. Increasing steel means decreasing spacing. Do you think I am that much weak? ಕನ್ನಡದಲ್ಲಿ ಅಷ್ಟು ಪೆದ್ದ ಅಲ್ಲ ನಾನು, ಗೊತ್ತಾ? ಹಿಂದಿಯಲ್ಲಿ मैं उतना बेवकूफ नहीं हूँ. ಆಯ್ತು ಬಿಡಿ. 0.341 ಯಾರದು ನಂಗೆ ಸಜೆಸ್ಟ್ ಮಾಡೋದು? ತಮಾಷೆಗೆ ಹೇಳಿದ್ದು, ಜಸ್ಟ್ ಫಾರ್ ಫನ್ ಐ ಟೋಲ್ಡ್. ಯಾರದು? ಯಾರೊಬ್ಬರು ಇನ್ಕ್ರೀಸ್ ಸ್ಪೇಸಿಂಗ. ಓ, ಯಾರೊಬ್ಬರು ಇನ್ಕ್ರೀಸ್ ಸ್ಪೇಸಿಂಗ್ ಅಂದರೆ ಗಾನ್ ಕೇಸ್. ಫಸ್ಟ್ ಆಫ್ ಆಲ್, ವೇರ್ ಆರ್ ಯು ಅಂಡ್ ವೇರ್ ಆರ್ ವಿ? ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. ಲೀವ್ ಇಟ್ ನೌ. ವೇರ್ ಆರ್ ಯು, ವೇರ್ ಆರ್ ವಿ ಮೀನ್ಸ್ ಇಫ್ ಯು ನೋ ಮೀನ್ಸ್ ಓಕೆ, ಸಫಿಷಿಯಂಟ್. I don't want to boost myself. Okay, leave it now. Increase to how much? 0.341. I want to raise to 0.341. So, go for reverse interpolation. Nodi, ee kadeyinda. See, now write here. Now, see, write this way. Tau C equal to 0.29 for PT equal to 0.15. And tau C equal to 0.36 for PT equal to 0.25. Therefore, for tau C to increase to how much value? 0.341 Newton per mm square. Tell what is the PT required. Fast. Interpolate this way. Actually, you can do it here only, or you reverse it and interpolate. Now some will tell. Sometime it happens. They will tell, sir, this way I know interpolation. This way I cannot do. Okay, then interchange and do it. Yes. Or you stand here and do it. Answer, PT. Now you should give PT more than 0.1608. You should give PT now more than 0.1608 to 0.2367. Thank you. 0.2367. That is what? But this PT equal to 100 AST by BD. Therefore, revised AST, new AST, revised AST required to control the shear is what? 0.2367 into B 1000 into D 646 divided by 100. Tell the answer. Revised AST. Revised AST required. Last time required steel was 1119 point something. Now it will come more. Now it will come more. Now it will come more. Bega, bega. Today only required. Approaching 9:30. Fast. See, two reasons. So partially, you should be blamed. Because when I started the class, actually I came 10 minutes late because some problem was there. Then when I started the class, you did not respond with the values. Second was actually my mistake of not charging, checking the charge. But you are also responsible. I told you in my class, if you feel I am commercial oriented lecturer, taking classes for money matter, I will tell frankly, then you don't tell anything. But nobody who knows me, they will tell that way. So that's why I tell at least some contribution. You remind me in the beginning, charging, that's all. One typing, I suddenly go and check the charge. See, such interruption should be avoided always. Now, why stopped? AST fast. See, suddenly stop now. See, almost 2 minutes over, you are not telling AST. Now I have to calculate. See, now I have to calculate. You are forcing me to waste time. 67 into 1000, ayo, calculate not on. 1600 or 1600.09. Okay, 1600.1 mm square. Okay, now even this sketch also I am removing. See now, AST required. Now 1 minute. Therefore, for which spacing becomes what? Spacing becomes pi by 4 of 16 square divided by 1660.1 into 1000. Answer fast. For which spacing becomes, I will put a line here to differentiate so that later I can check it. Tell the spacing. 1600 point something. I will use somewhere up to here. Spacing. Ayo, this much delay for spacing. It comes to 121.11, correct? I think 121 I got in my calculator. See, how you got 125? Ayo. Pi by 4 of 16 square divided by 1660.1 into 1000. 121 only comes. How you got 125? Which calculator you are using? Any outside made calculator where they don't know how to operate produce the calculator? 121.121. 121.121 or provide how much? Tell me. Now see, spacing came lesser. Earlier it was 175. Provide 16 torr at round off. 16 torr at round off. 121 came. This is good spacing. You don't go to 12 torr. 16 torr at how much spacing? Time over. 16 torr at 120 center to center. Okay. 120 millimeter center to center. Over. Now check for shear for lengthwise bending is same. Remember now. I will fast finish for widthwise bending. Can you do it yourself only? Tell me. Can you do it yourself only? Tell fast. If you can do it for yourself already 9:30, I will leave it for you. Work. You should give the answer next time. It will take 5 minutes. Can you do for yourself? See, widthwise bending, critical section comes here. At what distance? D from here. This is the area. Same way, can you repeat for widthwise bending and tell me answer in the next class? So that, or I will do one thing. I will take a photo and write it here. Next time you take screenshot. Okay, next time you take a screenshot. So I will take a screenshot of this one. Next time is tomorrow only. Ayo, tomorrow only. Tomorrow only. I will do one thing. There. I will write here widthwise bending. See, this sketch I will not write once again. See now. Tell me fast answer. D equal to fast at least. This is D. D equal to 0.694. Then tell me what is this length. Fast tell me. What is this length? 1.685 minus 0.694. Tell fast. 1.685 minus 0.694. Answer. You check for, consider what? Consider widthwise bending. 0.991. Okay. This is 0.991. Or I'll do one thing. Shall I finish fast in 10 minutes? 5 minutes? Tell me. Shall I finish fast in 10 minutes? Who will take it tomorrow? Shall I fast finish in 10 minutes, 5-6 minutes? Who will take it tomorrow now? Better finish today only. Okay, start. Shear force equal to, see now, start. Now, this value required by interpolation, this time I will not ask you. Why? Because I want to finish the question first. That value is 144.4. This value is 144.4 by interpolation. Now, shear force, look this side. It is 155.3 plus 144.4 divided by 2 into 0.991. 991 will give you shear force of, I only will do it. Why? Today only I want to finish the question. 148.5. 148.5. Factored shear force is 148.5 into 1.5 is 222.75. 222.75 kilonewton. So this is 222.75 10 to the power 3 by same number 0.329. It is 0.3295. Okay. Allowed shear stress PT. Steel provided is 16 torr at 180 center to center. Remember, widthwise bending steel is 16 torr 180. So divide by 180, it will give area of steel equal to 1000 divided by 180 into pi by 4 of 256. 1117.0 mm square. Therefore, PT equal to 1117 by this number. 1117 into 100 divided by 1000 divided by 676. 0.165. 0.1652. Now, come back here. 0.15 is 0.29. 0.25 is 0.36. Come back here. For 0.1652 by interpolation, you get 0.3006. Therefore, here also tau V is 0.3295. Allowed is only 0.3006. Here also not safe, marginal. Therefore, increase steel. For which one? For widthwise bending. Start. If you reverse it now, to get tau C equal to how much answer you want? We want tau C equal to, see, actual stress is 0.3295. Allowed is only this much. We want allowed to reach this number. So for tau C equal to 0.3295, your PT required is, I will do it. Why? I am not that much bad interpolation. Illide 3295. Then minus 0.15. That is 0.2064. Hope it is correct. Correct answer? 0.2064. Correct? Instead of PT 0.2064. Is it correct? Okay. If it is 0.2064, yet required is for widthwise bending 0.2064. It will come. Now you should work out 0.2064 into 1000 into 646 divided by 100 will give you 1333.3 mm square. For that one, spacing will become 1333.3 1000 will become reciprocal into 201 into 1000. 150.7 millimeter center to center. So can you tell me, provide 16 torr at what spacing? For widthwise bending, provide 16 torr at how much spacing? Last time you gave 180. 180 spacing is not sufficient. You have to reduce the spacing. Why? We have to give more steel. Tell the answer. What spacing you can give? First, last answer from your side. Last answer from your side. 150.72 is the calculated value. Round it off. Round off. Nobody gives 150.72. Bar bender will start cursing. Bar bender will tell, sir, where you came from? What is this, sir? Giving in decimals of fraction of millimeter. Provide 150 center to center. Okay. Therefore, over. Closing part of today is that column is 230 by 750, footing lengthwise is 4.1, widthwise is 3.6, and footing slab is 750 mm, lengthwise steel is 16 torret. Estadu? Forgot it. 16 torret. I forgot. If this way, if I forget what to do. 120. 16 torret. 16 torret, 120 millimeter center to center. Widthwise steel is little lesser steel. 60, this lesser steel because spacing more. 16 torret, 150 millimeter center to center. This is the final output. When you go to ETABS&SAFE, nothing to be done. Prepare the model 4.1 by, this I am telling for ETAB people, 4.1 by 3.6 meter. Place the column. Apply that load and couple. Then tell it, thickness you provide. See, run. It will tell everything. Only thing is, diagonal tension shear, it will not check. For that, use Excel sheet. I told you. Oh, sorry, forgotten. See, for checking shear, we have Excel sheet. I suddenly forgot it. So do one thing. We prepared Excel sheet earlier. So those who prepared Excel sheet, now check all these values using Excel sheet. Okay, done. Can you do it? That Excel sheet, okay, here, okay, no problem. This is manual design class. But in the ETABS&SAFE class, I will tell you use Excel. Agreed or not agreed? Agreed? ETABS&SAFE class, I will tell you use Excel for all this. If you want principle, refer to earlier class. Clear or not? Principle, refer to earlier class. In software class, no discussion of principle. There, principle of software, not the structural principles. You are not answering. Clear now? Their structural principle will not come. But even then, little I may tell. Not that I may not tell. So all the structural background are covered by me, is covered by me in the classes running now. Okay. Thank you. Tomorrow we will meet at 5 o'clock. Tomorrow I will see that charging is taken care. So, but still for safety, I see today I put class extended. That photo, that thumbnail I prepared earlier only. Every day what I do is I take a dummy thumbnail and put a dummy I put a dummy live class there. I make it unlisted. When emergency comes, I will make it public and send the link. So one disturbance okay. Second disturbance means I had once again plan. Then it will take at least 15 minutes more. Okay. See you tomorrow. Tomorrow we will continue. Already much more than required time now. Okay. अब्बा मुख तो क्या